Hello everyone, welcome back to my channel. So in this video we'll see some more problems on Laurent series when region of convergence is given for you. Okay, so if he has given the region of convergence, then you have to be careful in the expansion. Okay, so we can't directly do by taking the expansion as you think. Okay, so what is ROC? He has given R2 less than Z minus Z naught. Actually ROC is Z minus Z naught less than R1. Okay, so in the place of R2 now we have 1 mod Z minus 0, okay, less than, this is 2. Okay, that means he is asking the expansion about Z is equal to 0. He is asking the expansion of f of z about z is equal to 0. That is what you are getting the inference from the ROC given. Okay, this is very important, right? So from the ROC we are getting the value of z naught. So z naught value is equal to 0. And R1, that is C1, is a circle of radius 2. C1 is a circle of radius 2 and C2 is a circle of radius 1. Okay, now the center of the series is 0, so that is origin. So you have a circle like this of radius 1 and there is a circle like this of radius 2 and center here is origin 0. Okay, this is what he has given. So when you are given with a problem like this, generally we have to do by using binomial expansion only. Okay, so generally we have to do by using binomial expansion. If there is no ROC given for you, if there is no condition given for you, then you can solve directly as we have solved in the previous video. So we have done one problem in the previous video, so you can do like that only, right? If the region of convergence is not given for you. But when region of convergence is given for you, you have to be very careful, right? So now the region of convergence given is 1 less than modulus z less than 2. So we know that when you are expanding in binomial expression, suppose 1 minus x whole power 1 minus 1, so it will be 1 plus x square plus x cube and so on. That is okay, but the condition here is mod x less than 1. So this condition has to be satisfied. So this condition has to be satisfied by both the circles. So I am taking the first circle condition, so 1 less than mod z. So we need of this form, so send this z this side, so it will be 1 by z less than 1. 1 by z is less than 1. So now we have to expand in terms of 1 by z so that it will be less than 1, so that you can apply the binomial expansion. Right, so in the second condition mod z is 2 less than 2, so it will be z by 2 less than 1. So this is the condition which you have to satisfy. That is, for negative powers of z you have to take 1 by z less than 1. For positive powers of z you have to take z by 2 less than 1. Okay, so in terms of z by 2 you have to expand for positive powers, in terms of negative powers you have to expand 1 by z. Okay, so 1 by z less than 1. Right, let us see how to solve this. F of z is equal to, I'll explain you, don't worry. Okay, z square minus 3z plus 2, z square minus 3z plus 2. So this can be written as 1 by z minus 1 into z minus 2. So you can have to do partial fractions, a by z minus 1 plus b by z minus 2. So a value is obtained by substituting z is equal to 1 in this, z is equal to 1 by not considering this. So 1 by z is equal to 1, so 1 minus 2, 1 minus 2 is minus 1, so it will be minus 1. Next, b is obtained by substituting z is equal to 2, b is obtained by substituting z is equal to 2 by not considering this term. So it will be 1 by 2 minus 1, z is 2, so 2 minus 1 is 1, so you will get 1 here. So f of z can be written as 1 by z minus 2. So I am writing this because b is positive, minus 1 by z minus 1. Okay, so Now we have to consider 1 by z. So it is z by 2 less than 1. So when you want to have z by 2 in terms of z by 2 only, you have to write the binomial expansion. So in order to have this 2, so I am taking 2 common here. 1 by 2 if I take common, so this becomes 1 by z by 2 minus 1. Z by 2 minus 1. So this minus, so we need 1 by z form. So I am taking 1 by z as common, right? So 1 by z as common if I take, so it will be 1 minus 1 by z. Okay, so 1 minus 1 by z, right? So f of z is, so 1 by 2 into, so if I take a minus common, so minus if I take common, what will it become? 1 by 1 minus z by 2. Z by 2 minus 1 becomes 1 by z, 1 minus z by 2. Z by 2 minus 1 becomes 1 minus z by 2. That's all. So minus 1 by z into 1 by 1 minus 1 by z. So f of z can be written as minus 1 by 2 into 1 minus z by 2 whole inverse. So this going to numerator, so if you shift this to numerator, so it will become 1 minus z by 2 whole inverse. So minus 1 by z into 1 minus 1 by z whole inverse. Okay, so now this z by 2 is mod z by 2 is less than 1, yes or no? So from the given ROC, mod z by 2 is less than 1. So you can apply binomial expansion for this series, and 1 by z is also less than 1. So 1 by z is also less than 1. So you can apply binomial expansion for this series as well. Okay, right. So minus 1 by 2 into this becomes 1 plus z by 2 plus z by 2 whole square. So here negative and here is also negative. So 1 minus x whole power minus 1 is 1 plus x square plus x cube and so on, plus z by 3 whole cube plus so on, minus 1 by z into 1 plus 1 by z plus 1 by z whole square plus so on. Okay, so this is the binomial, this is the expansion of this series. So if you want to write in terms of summation, so what can you write? 1 by 2 into summation n is equal to 0 to infinity, right? This can be written as z by 2 whole power n. So if you substitute n is equal to 0, you'll get 1. Z by 2 whole power 0 is 1. If you substitute n is equal to 1, z by 2 whole power 1 is z by 2. So you'll get the second term. If you substitute n is equal to 2 here, z by 2 whole square, third term, 3 z by 2 whole cube, okay, and so on, minus, okay. So if you multiply this also, what you'll get, if you multiply this, minus 1 by z, right, minus 1 by z, minus if you keep as it is, so 1 by z into 1 is 1 by z, plus 1 by z into 1 by z is 1 by z square, plus 1 by z into 1 by z square is 1 by z cube, plus so on. Okay, so you get this term, right, 1 by z. So if you want to write in summation form, how can you write summation? N is equal to 1 to infinity, 1 to infinity, it will be 1 by z whole to the power of n. Okay, so if you substitute n is equal to 1, you will get the first term 1 by z. N is equal to 2, you will get the second term 1 by z square. N is equal to 3, 1 by z cube, and so on. So this will be the principal part, and this will be the analytic part, because it has positive powers of z, because we are expanding about z is equal to 0, so you'll get z minus 0 terms only. Z minus 0 is z term only. Okay, so if it is this is consisting of positive powers of z, so this is analytic part, and this is consisting of negative powers of z, so this will be principal part. Okay, right, so this represents the principal part and this represents the analytic part. Okay, so let us see one more problem, then you'll understand more clearly about this ROC considerations. Okay, right, we'll see one more problem on Laurent series. Okay, so he has given some function f of z and he has also given the region of convergence. Okay, so when he gives the region of convergence, you have to be more careful. Okay, so what does it represents? R2 less than z minus z0 less than R1. Okay, so R2 is 3 and R1 is a circle of radius 5 and R2 is a circle of radius 3, that is C2. I mean C2 is a circle of radius 3 and C1 is radius circle of radius 5. So when he has given like this, we know that in order to apply binomial expansion, okay, so if you are expanding in binomial, so if you have 1 minus x whole power minus 1, so we can write 1 plus x square plus x cube plus so on, that is okay. But for this the condition is mod x is less than 1. Okay, this condition must be satisfied. So for this to be satisfied, what are the conditions we have to take? So 3 is less than mod z by 2. So we need of this form. So we need of this form means what can we write? 3 by z plus 2. 3 by z plus 2. Mod 3 by z plus 2 is less than 1. That means you have to expand the series in terms of this term, that is 3 by z plus 2. That is the inference which you have there for this. Okay, so this is the typical problem. Please try to understand clearly. So if you, because when we have a function like this, we can't directly find the Laurent series. Okay, so we have to take the partial fractions and expand using binomial expression. So while expanding using binomial expansion, since you have two limits now, in Laurent's entire series you don't have this problem because we have only one circle enclosed, but here two circles are enclosed. Okay, so that is why we have this problem. Okay, so what we have to do is we have to take the first limit. 3 is less than mod z plus 2, this I am taking. Okay, 3 is less than mod z plus 2, but we need some value of x within of this form. Mod x should be less than 1, then only we can expand the binomial expansion for this. So in order to obtain for this, send this z by 2 towards left hand side. So modulus of 3 by z plus 2 is less than 1, that is you have to expand in powers of 3 by z plus 2. Similarly, mod z plus 2 is less than 5, so z plus 2 by 5 is less than 1. Okay, so next if you have another series in terms of z plus 2, we have to expand, so in terms of z plus 2 plus 5. Okay, so these are the first 2 points which you have to remember in order to solve a Laurent series problem which is given with the ROC. Okay, now see, so f of z is equal to z square minus 6z minus 1 divided by z minus 1 into z minus 3 into z plus 2. So we'll do partial fractions, a by z minus 1 plus b by z minus 3 plus c by z plus 2. Okay, so how will you get the value of a? A is obtained by substituting z is equal to 1 by not taking this. So it will be 1 minus 6 minus 1 divided by 1 minus 3 is minus 2, 1 plus 2 is 3. So this and this gets cancelled. Minus 6 by minus 6, you'll get a is equal to 1. Similarly, what is the value of b? So b is given by z is equal to 3. If you substitute z is equal to 3, so 3 square minus 9 minus 6 into 3 is 18 minus 1 divided by, if you substitute 3 here, 3 minus 1 which is equal to 2, so this should not be considered, and z plus 2, 3 plus 2 is 5. So 9 minus 1 is 8, 8 minus 18 is minus 10 by 10, so it will be minus 1. And then c is obtained by substituting z is equal to minus 2. Okay, so minus 2 whole square is 4, minus 6 into minus 2 is plus 12 minus 1 divided by, just substitute z is equal to minus 2 here, so minus 2 minus 1 is minus 3, minus 2 minus 3 is minus 5. So this will be 15 by 15 which is equal to 1. So therefore what is f of z then? So f of z can be written as a is 1 by z minus 1, b is minus 1, so minus 1 by z minus 3 plus c is 1, so 1 by z plus 2. So until now we have found the partial fractions. right? So he has asked to find the expansion in terms of z plus 2, that is about z is equal to minus 2. Okay, he has asked to us to find the expansion. That is what we are getting the data from the given ROC. So ROC is R2 less than mod z minus z0. So z minus z0. So he is asking the expansion about z is equal to minus 2, so that it becomes z plus 2, right? So z plus 2 is equal to some p. Let z plus 2 is equal to p. Okay, so this now becomes f of z is equal to 1 by, so z plus 2 is equal to p, so z is equal to p minus 2. Z is equal to p minus 2. So this will become, or this consideration is also not required for us, I think. Okay, so this consideration is not required for us in this problem. Okay, so about z is equal to minus 2 you are expanding. So how can we write this in terms of z plus 2 we need? So I can write z plus 2 minus 3, so that it becomes again z minus 1 only, minus 1 by, so z minus 3 can be written as z plus 2 minus 5 plus, this is z plus 2 only, so I'll write as it is. Okay, so we need to convert this in the form of 3 by z plus 2. So 3 by z plus 2 you have to get, right? So you have to convert this in the form of 3 by z plus 2. So what you have to take common is, you have to take 1 by z plus 2 common. 1 by z plus 2 I am taking common, so this becomes 1 by 1 minus 3 by z plus 2. Okay, minus, you have to get in the form of z plus 2 by 5. So I am taking 5 common, so 1 minus 1 by 5 into 1 by z plus 2 by 5 minus 1. This is anyhow 1 by z plus 2 only. Okay, right, so this is 1 by z plus 2 into 1 minus 3 by z plus 2 whole inverse. Okay, this going to numerator, it will become whole inverse. So I am taking a negative here, a common, so I am getting minus of minus is becoming plus here. Okay, I am directly writing, so this becomes now 1 minus z plus 2 by 5 whole inverse. This going upside by taking a negative common. If we send this to numerator, so this becomes 1 minus z plus 2 by 5 whole inverse plus 1 by z plus 2. Right, so now we can expand, because this value is less than 1, mod x less than 1, and this value is also less than 1 from the given ROC. We have taken these considerations because ROC is given for you. Okay, so this value is less than 1 and this value is also less than 1. Now we can apply binomial series expansion. So f of z is given by, now tell me, so 1 by z plus 2 into, right, so 1, so both are negative, here is negative and here also it is negative, 1, so 1 minus x whole inverse is 1 plus x square plus x cube plus so on. In the place of x, now you have 3 by z plus 2, right? So 1 plus 3 by z plus 2 plus 3 by z plus 2 whole square plus so on, right? Right, next plus 1 by 5 into, so this is negative and this is also negative, so same formula. In the place of x, now you have z plus 2 by 5, 1 plus z plus 2 by 5 plus z plus 2 by 5 whole square plus so on, plus 1 by z plus 2. Okay, so this is infinite series. If you want to represent in summation form, then how can you represent 1 by z plus 2 into summation n is equal to 0 to infinity 3 by z plus 2 whole to the power of n? Yes or no? So if you substitute n is equal to 0, this becomes 1, so that is the first term. When you substitute n is equal to 1, that becomes 3 by z plus 2. When you substitute 2, you will get 3 by z plus 2 whole square, z plus 2 whole square, and so on. So this can be represented like this. plus 1 by 5 into summation n is equal to 0 to infinity z plus 2 by 5 whole to the power of n. Okay, in the same way you can represent like this, plus 1 by z plus 2. Okay, so this is the Laurent series expansion for the given function. Okay, so if you observe here, this represents the analytic part, because you have positive powers of z plus 2. So this represents the principal part, and this also represents the principal part, because you have negative powers of z plus 2. Okay, so we have both principal part and analytic part, therefore this represents the Laurent series expansion. Okay, so I hope you have understood how you are going to solve the problem when you are given with some ROC. So be careful when you are given with ROC. Okay.